Okay, this is question number 10A. Uh, so uh, over here, what we simply do is to deal with the surd, we write it in its broken up form. So I know it's root 9 and root 7. With this, I'm able to cancel this and we end up with 1 over root 7 because root 9 is 3. So the 3's and 3's cancel out. And when it comes to rationalizing the denominator, all I need to do is multiply the top and the bottom of the equation by root 7. Hence, I end up with root 7 over 7. Okay, for part B, we are going to do something very similar. We are going to split up the root 20 into its surds. So I know that it's root 4 times root 5. With the 2 over here, it's going to, again, be, I can say this as root 5 times root 9. And this is minus root 16 and root 5. When it comes to splitting these up, I'm always trying to look for a square number. And the reason why is because once I see something like a root 4, 9, or 16, I know that they can be further simplified. Yeah. Furthermore, everything will be in terms of root 5. So this will make the calculation really easy. So it will be 2 root 5. That's not bright in red to confuse you with the other question. Let's stick with our blue. So we've got 2, or green. We've got 2 root 5 plus 6 root 5 minus 4 root 5. And overall, my answer is going to be 4 root 5 because we've got 8 root 5 minus 4 root 5. Let's move on to question 11. With this question, it says we've got to find the exact value when x is equal to 25. Now, this is going to be a simple substitution. So once I sub that in, if I sub that into my calculator, I get my answer as 21877. Okay, for part B, we need to factorize this expression and show that your answer to part A can be written as a product of two prime factors. Now, this question seems daunting, but let's try factorizing it and solving it. Simply, what I would do is, because we need to write it as a product of two prime factors, I am simply going to write it as 35x squared and plus 2x minus 48. Now, this is what we have to work with. We need to split up into two factors. So I'm going to pick 42 minus 40x. Now, the reason why I picked that is because these two are similar. Okay, 42 minus 40x will cancel down to 2x, but at the same time, 35 and 42x will correlate, and 40x and 48 will also correlate. And you'll see in a second why that is. So let's write that in, 35x squared minus 48. So we've then got 7x multiplied by 5x plus 6. And then we've got minus 8, 5x plus 6. And now I know that when I have something like this, because it's 5x plus 6, I can take this in common. Okay, when it comes to factorizing, this is the highest common factor between both of these terms. So I can take this in common and write 7x minus 8. And this is an alternative method of factorizing. Okay, you do not need to know this method in the exam. If something like this comes up, I would recommend putting this into your calculator, getting out the answers and reverse engineering it. Okay, so just to, if you were to put it in your calculator, the answers that you would get from the calculator method would be minus 6 over 5 and 8 over 7. Now, all you need to do is reverse this, because remember, the calculator is going one step further than this question, and it's actually solving this. It's essentially solving 5x plus 6 equal to 0, which is 5x equal to minus 6, so x is equal to minus 6 over 5. And then again here, it's doing the same thing. So here, x is equal to 8 over 7. Okay, that's why it's getting these answers. So all you need to do is go backwards, and then you can make up the question by expanding it. Okay, this is how you would show this. But don't worry, something like this wouldn't be asked in the exam. Okay, let's move on to some expand and simplify type questions. To start off with over here, nice and easy, we've got 3 root 2 plus root 10. For part B, we've got 10 plus 2 root 3 minus 5 root 5 minus root 15. And what I know is I think that would be fine to leave by itself. So let's just write that slightly nicer. I don't think it's come up that way. And then finally, our part C is just going to be the same sort of concept. So it's going to be 24 minus 6 root 7 minus 4 root 2 plus root 14. Nice and easy expand and simplify type questions. Now, this is where the fun begins. We've got to rationalize the following. Okay, so let's get started on this. For the first, for part A, I am simply going to multiply the top and bottom by the denominator. So I'm going to end up with root 3 times root 3. So I'm going to end up with root 3 over 3. For part B, I'm going to multiply by the conjugate. So that's root 2 plus 1. So remember, we use the difference of squares technique here. So it becomes root 2 plus 1 over root 2. So over that, we can use a little trick because root 2 times root 2 is 2. And then minus 1 squared. We remember what we're doing over here. We're using our a plus b, a minus b equal to a squared minus b squared formula. And that's how we're solving this. So it would equal to root 2 plus 1, as 2 minus 1 is 1. So dividing by 1 would leave our answer as the following. Part C. I forgot to change the color. I'm so sorry, guys. So 3 over root 3 minus 2. What I'm going to be doing over here is root 3 plus root 2. We're multiplying by the conjugate. Remember, this is a very, very important step. So we're going to end up with 3 root 3 plus 3 root 2 over 3 minus 4, which, oh, hang on, it's going to be 3 minus 2. So my answer is simply going to be 3 root 3 plus 3 root 2. I believe that should be fine. So just to re-clarify this, oh, apologies guys, there was never a root over here, so we just need to adjust this. I'm just going to make a quick adjustment. This is going to be times by 6. Yeah, so there was never anything here, so it would in fact end up be minus 4. Apologies, there was never a root there. I simply made a mistake and copied it down wrong. So hopefully that makes sense. I'm just going to run through that one more time. So we're using the conjugate. So we're multiplying by the conjugate. So that would be root 3 plus 2 over root 3 plus 2. That does not need to change. Let's move on to part D. Again, this looks a bit daunting, but it's just going to be root 23 minus root 37 multiplied by root 23 minus root 37. So we are multiplying by the same number on the top and the bottom. That's why it works. Okay, so with this, it's going to be root 23 minus root 37 whole squared over 23 minus 37. Unfortunately, I'm getting way too ahead of myself, and we should probably simplify this previous question. So I'm just going to write it as minus 3 root 3 plus 6. And that's because 3 minus 4 is minus 1. So we just need to negate this whole expression. Okay, let's continue with what we were doing. So here we are going to get, when we do 23 minus 37, we end up with, yes, can you tell me? That's correct. We are going to end up with minus 14. Right. So it's going to be, when I expand this out, I'm going to get 23 plus 27. And because here what I'm doing is I'm using my a minus b whole squared identity. So my a minus b whole squared identity would equal a squared minus 2ab b squared. So the middle section is simply just going to be minus 2 root 23 root 37. And that's something that we will need to multiply. So using my calculator over here, I'm going to get 60 because I've got 23 plus 37. What am I doing? It's obviously been a long day. It's going to be plus 37. So it's going to be 60 minus 2 root 851 over minus 14. And since everything is divisible by 2, I'm going to cancel this down further. So it's going to be 30 minus 2. So 30 minus root 851 over minus 7. And we can leave our answer in this format. Okay, let's move on to part E. So here we've got a little bit of a trick question. All we need to do is multiply out the denominator. So I'm going to write this as 2 plus root 3. Okay, and what we do for this is we simply expand all of this out first. Okay, we're simply going to expand all of this. When it comes to the expansion, I get 4 plus 2 root 3 plus 2 root 3 plus 3. So I end up with 1 over 7 plus 4 root 3. And this is what I do the complex conjugate of. So the conjugate, I forget the word complex, the conjugate of this is 7 minus 4 root 3 multiplied by 7 minus 4 root 3. It's just going to be the opposite sign. And then we do this, we do the same method as before. So I get 49 minus 28 root 3 plus 28 root 3 minus 48. And that's the full expansion, so we don't need to show that middle step. I'm just showing you for the sake of this. So 49 minus 48 is 1, so we're simply just going to end up with 7 minus 4 root 3. Okay, let's move on to our final part F, which is a very similar sort of question. If you guys can, please try and pause the video and do it yourself, and then I will go over it. Okay, let's have a go at that now. Which color should we do? I'm going to go for a pink this time, just to mix it up. So we've got 1 over 4 minus root 7 multiplied by 4 minus root 7. So this is simply going to give me 1 over 16 minus 8 root 7 plus root 49. So I'm going to get 1 over 23 minus 8 root 7. So I'm going to be multiplying this by my complex conjugate, which is going to be 23 plus 8 root 7, 23 plus 8 root 7, like this. And now all I need to do is continue with this question. So I'm going to get 23 plus 8 root 7. And then on the bottom, I'm just going to end up with, it's going to be a big number, 529, if I do 23 times 23, minus 448, which means that I will get 23 plus 8 root 7 over 81. And that is my final answer. Hopefully this makes sense. I know this is quite tiring and long, but we are nearly there. Okay. Thank you very much for listening.